Hi everyone, this is the third and final video for section 8.2 on adding and subtracting integers. So in the previous two videos, we've really just talked about models of adding and subtracting integers. And these models really tell us what the algorithms are. We're not going to talk about any algorithms explicitly, just because we all add and subtract integers all the time. So what I really want you to take out of this are the models and then some of these properties. So we have a lot of properties that we've talked about from whole numbers back in chapter 3, and a lot of these were on exam 1 and the exam 1 review. So you should take the time to go back and look at those, just because to make sure you remember what it means for an operation to be commutative or associative or have an identity or have an inverse. Oh, well, we're going to talk about inverses right here, or have an identity. Okay, so go back and review those, but we're also going to talk about something called inverses, and we haven't talked about this so far, I believe. So every integer has what we call an additive inverse. And so all that is that it's an integer such that the sum of that integer and its inverse is 0. So remember that 0 is what we call the additive identity. And so 0 is the additive identity. And so remember that all that meant was that 0 plus any number didn't change the number. We just got back the same number that we started with. And so we know that 0 has this really nice property. And so we like 0. We like using it because it doesn't add any value. And you can see whenever we were using our sign model, we used 0 pairs because it didn't change the value. That was one thing I should have noted in those videos. So whenever you add 0 pairs, you're just adding 0. And we know that 0 is the additive identity and it doesn't change the value of the problem. So that's why we like 0. So if we have any number, we want to know, well, can we change that number through an operation and get to 0? And the answer is yes. You can do that using these additive identities. So if we have a real number a, the additive identity is minus a, right? It's the number with the opposite sign, because we know that whenever you have a things and you add negative a, that means you get 0 because everything cancels out, because everything in a has an opposite sign from everything in minus a, right? That's why we call it its opposite. And so this is the additive inverse. We just have any number and you change the sign. So essentially what we're doing is we are changing the sign to get the additive inverse because we know that the signs will cancel. And the reason that we haven't talked about this until now, that we're just adding it now, is because none of our other numbers had additive inverses because we didn't have subtraction. We didn't have negatives, rather. So remember that the whole numbers are just the set of the counting numbers, right? The natural numbers and 0. So it's 0, 1, 2, 3, 4, 5, and so on. Whereas the integers is the set of all of the whole numbers and their opposites. And the additive identity is just the opposite of a number. So we didn't have these negatives before, so we couldn't talk about these inverses. We needed the negative signs to talk about it. And so that's why we're introducing it now. And one thing to note is, like I said before, we really like 0 because when we add in 0 pairs, the value of things don't change. And the 0 pair that we used in the sign model is an example of additive inverses. Whenever I first introduced it in the first video for this section, we noted that -1 plus 1 is 0, right? We all know that. And that's because 1 and -1 are additive inverses. 1 and -1 are additive inverses. They're also opposites. They have opposite sign. And so these are all ways of just saying the exact same thing, that 1 plus -1 is 0, 1 and -1 are additive inverses, 1 and -1 are opposites. All of those just tell us the exact same thing. So how can we use additive inverses with subtraction? So we can use this to help formalize what we've been talking about the whole time, is that these negatives and minus signs cancel. So just like I said verbally, we can think of an additive inverse as the opposite of a number. So we can think of an additive inverse just as the opposite of a number. Right, so the additive inverse of 1 was -1. The additive inverse of 2 is -2. The additive inverse of -3 is +3, and so on. You just change the sign. So in general, if we have a negative sign in charge of some parentheses, that indicates the additive inverse or opposite, as is an equivalent way of saying this, or opposite of the expression inside the parentheses. So anytime we have a negative sign in front of a pair of parentheses, we just know that whatever's inside there, we're just thinking about the opposite of it. So in the expression 4 minus -3, we can think of minus -3 as just +3, right? Because the opposite of -3 is +3. We just change the sign. So whenever we're thinking of 4 minus -3, we can really think of it as just combining 4 we're combining 4 and the opposite of -3, which is 3. So we can think about it as 4 plus 3. This isn't worded the best, but when we're looking at 4 minus -3, we can think of that as combining 4 with the opposite of 3, with the opposite of -3, right? Which is just 3, so we can think of it as 4 plus 3. So having these properties of additive inverses can kind of truly then formalize what we're doing when we are adding and subtracting negatives, is that it's just subtracting the positive, adding or subtracting the positive. Okay, so this this property is also on page 305, essentially. Yeah, and on page 305 it says that a minus b is a plus -b, and that's what we just kind of wrote down here. And this is how everything works together. Okay, so this is all I wanted to talk about from section 8.2. Yeah, so the homework shouldn't be too difficult because you all know the answers without doing any real work. Yeah, so that is all for this video.